Hey guys, Mr. A here. Today, let's talk about surface area. First, what is surface area? The only thing surface area is, it's the area of the outer surface of a 3D shape. Sometimes it's represented by a net. Right here, I've drawn a kind of poorly drawn, forgive me, I'm no artist. I went ahead and drew a cube, and I drew it if you were to unwrap it. All right? So how is surface area going to be useful to you? Well, an example that I gave some of my students is, since a few of them really like watching plays and watching skits, I asked them what would be a good use of a chest if you wanted to paint it for. And a bunch of them told me about Treasure Island, and I went ahead and went with it. Now, there are certain types of paint that you can use on a box that will make the box look old, make it look distressed. And if you use too much of that paint, it's just going to look all glossy and it'll look totally fake. So you have to know the surface area of that box, so that way you know exactly how much paint you're going to have to use for the surface of the box. Now about Annette, I was talking about that just a second ago. Annette is a 2D figure that's used to represent a 3D shape. An example right here would be this cube being represented by this net. Another couple examples would be these. These are nets that I borrowed from another math teacher, and it just kind of demonstrates how a shape will look when it's completely unfolded, like this rectangular prism. You roll it up, and we have a nice little tube of rectangles right here. Fold down the two flaps on either side, and voila, we have a little rectangular prism. As for the other kinds of shapes you might run into, I've got here the triangular pyramid. What you're going to do is you take the base, which is a triangle, that's what identifies the name of the pyramid, and we attach a triangle to each part of the base, fold it up, and we've got ourselves a nice little triangular pyramid. The last shape I'll talk to you about is a triangular prism. All it is, same thing as the rectangular prism. When you fold up the sides, you have a nice little rectangular tube. All the sides are made up of rectangles. Except this time, the two flaps on the end are made of triangles. See that? Nets are also super useful whenever you try to find the surface area of a shape. In order to find the surface area of pretty much any shape, all you've got to do is find the area of all of the present shapes and add them together. For cubes, it's especially easy. In a regular cube, all of the sides, the length, the width, and the height, are all going to be the same length. So, if the length is going to be 3, that means the width is 3. If the width is 3, that means the height is 3. All right? So, in order to find the area of just one of these boxes, all you have to do is do length times width. Just 3 by 3. And that's going to give me an area of about 9 units. Well, if that's going to be 9 units, and this is a perfect cube, all of the sides are going to be exactly the same. All of these sides are 9 units. There is a shortcut you can take, and this only works with cubes. Don't try this on any other prism. All you have to do, since you have 6 identical sides, you can take that 9 and multiply it by 6. Excuse me for not being able to write the number 6. You take 9 times 6. For those of you who don't know this trick, you can use a finger trick if you're not super comfortable with multiplication. 9 times 6. Take a look at my hands. All you're going to do is count. 1, 2, 3, 4, 5, 6. You put that finger down, and you've got 5 on this side, 4 on this side, 54. Your final answer for this problem should be 54 units squared. All right, you're not going to be calling this 52 units cubed. We are finding surface area. We are not finding volume anymore. Moving on to example number 2. I know I drew this kind of funny, seeing as all of those squares look kind of the same, and yet the numbers are all different. That's because this would be a better representation of how a rectangular prism might look. A rectangular prism is going to have 3 different sides, but that's okay. Because here's how you're going to find the area of this prism. What you do for this cube right here, we've got 3 by 4. 3 times 4, of course, is 12. So we're going to write that in here. This part, we have this 2. Do we know the height? Take a look at the numbers around there. It's going to be 3. The height's going to be 3. We got 2 by 3. That gives me an area of 6. Now, I don't know if you paid attention earlier when I held up this net right here, but there's usually going to be a pattern. If all 4 of these rectangles are not the same, there will tend to be a pattern. Simply because in a typical box room, or any typical box of anything, the front is usually the same as the back, the ground is the same as the ceiling, and the right side is the same as the left side. So if I have a normal shape and assume that that's the top and that's the front, that means this is the bottom, which is also 12, and this is the back, which is also 6. 12, 6, 12, 6, all the way down. Now for the sides, you have to keep one thing in mind. You have to keep in mind which sides are being shared by which parts of this prism. If you look at this shape, if I fold it up, fold this edge down, and fold this edge across, these 2 edges are actually going to meet. However long this rectangle is, that's how tall this rectangle is. So, right here, this edge here, we know that this is going to be 2 units because the other side was 2 units. So if that side's going to be 2, if we folded this up, that's also going to be 2. So we have the height of this rectangle. Now we just need the width of this rectangle, which I'm sure many of you took a look and saw that there's a pattern to these numbers as well. 4, 2, 4. This one's also going to be 2. So the height of that's going to be 2, which means the width of this rectangle is 4. And the width of this rectangle is 2. Okay? And the height of that is going to be 4. 4 by 2, that gives me an area of 8. 2 by 4, again, that gives me an area of 8 units. Your final step is going to be to add all of those numbers up. No shortcuts like we took with the cube last time. We're going to do 12 plus 12. That gives me 24. 24 plus 6 plus 6, that's adding another 12. So 24 plus 12, that is 36. 36 plus 8, that's going to give me 44. 44 plus 1 more 8, that's going to give me 52 units squared. 52 units squared. Final answer. Okay? Sometimes, however, you're not going to have a net to work with. You're going to be given a shape, and you need to know how to find the surface area of this shape without having a net. Now, this is a part where a lot of your teachers may have shown you a formula. It says length width plus width height plus length height. Then you add all that together and you multiply it times 2. That works, but it's a little wordy, and I don't like teaching wordy little algorithms of how to do things. I like explaining what is happening with all those formulas. So I have a different method. It's essentially the same, but I call it front, ground, side, FGS. And this is how I set up my problem. I have FGS all up there, and then down here I've got times 2. And this is how I set up problems for a rectangular prism. This won't work with any other shape, but all you do is you set up FGS, front, ground, side, because that's all you need at first. So step 1, let's go ahead and find the area of the front of this shape. We're going to use this 6 right here on the height. So 6 times the height, it looks like it's going to be 4. So 6 times 4, that's going to give me an area of 24. I'll write that down for the front. Next comes the ground. The ground is a little bit hidden, so let me draw a little dotted line so we can see it. The ground is going to be right here. It's going to, again, have a width of 6, only this time the ground has a length of 2. So this time, instead of 6 times 4, I do 6 times 2. That's going to give me 12. Finally, I'm going to use the side, this area right here. We can see it nice and clearly. It looks like it's going to be 2 by 4. 2 by 4, that's of course going to give me 8. All right, What's next? I got the front of my room, I've got the side of my room, and I've got my ground. But there's a problem. If I have the front, ground, and side, I've only got about half a room. Rooms have 4 walls, ceiling, and a floor. I've only got 2 walls and a floor. So I've got to double it. I'm going to add all this together. 12 plus 8 gives me 20. 20 plus 24 gives me 44. Now I've got 44. I've got to double it in order to get the other half of my room. So I take 44, multiply it times 2 to give me a final surface area of 88 units squared. 88 units squared. That's it. This is how you would find the surface area without using Annette for just about any rectangular prism you could come across. Now on to part 2.